Hello, today we're going to look at solving quadratic equations like this using a quadratic formula or the quadratic formula. Now what I'm going to do an example where we can solve it by factorizing, get our answers there, and we're going to then solve it using the quadratic formula and show you get the same answers. So solving this quadratic equation, first thing to check for factorizing, is there a common factor? Nope. Is there a difference of two squares? No. Is it the 1x squared? Yes, it's the 1x squared, so it must be the pattern. So two terms multiply to give us -6, and if I put the number in front there, I should have 1 there, add together to give us the 1. So two terms that multiply to give us -6. Let's try 3 and -2. They multiply to give us -6. Do they add to give us the +1? 3 plus -2, yeah, +1. Excellent, found the solution straight away. So set up our brackets. It's x squared in the quadratic equation, therefore it must be x multiplied by x. And we've got our numbers up here. So the +3 and the subtract 2. And then if ever you're unsure about your factorizing, expand it back using crab claw. Now we're down at the stage, two terms multiplied together to give us 0, therefore either of those could equal 0. So in this one, or in this case, subtract 3 from both sides, so we get x equals -3. In this case, add 2 to both sides, so we get x equals 2. So our final solution is x equals 2 and -3. And you should always check them back in the original equation to check they actually work. We won't spend time on that just now, but I'm sure you'll do that when you're working through these. Right, now we're going to solve the same equation, but we're going to use this thing called the quadratic formula. Now this is the quadratic formula. It may look a bit complicated, but let's use it. Let's show how it's applied. If you're interested where it comes from or where it's derived from, ask your teacher, and or maybe investigate yourself would be the best idea. But I'll show you how it's applied. Right, so we've got our quadratic equation, same as before, so we know what answers we're going to get. And we want to find the values of a, b, and c to pop in this formula. So what we do, we compare this equation here to the general equation. So ax squared, that's a general quadratic equation, plus bx plus c equals 0. And then we get our values from there. So if we compare the x squareds, let me change colour. Compare the x squares, let's put the 1 in front of there because it is 1x squared. So if we compare those, you can see that the a equals 1. If we, oh sorry, another 1 here, there should be a 1 there, because it's 1x. If we compare the b's, you can see b also equals 1. And for the c, just be a little bit careful here, plus c equals -6. So in other words, c equals -6. So now we've got our values of a, b, and c. We can pop these in the quadratic formula. So b, that's 1, so it's -1, plus or minus the square root of b squared. b is 1, so it's 1 squared. Subtract 4, a is 1, so multiplied by 1. And c is -6, so multiplied by -6. And all over 2a, that gives us 2. So underneath the square root, what do we got? Let's do multiplication first, BIDMAS, or no, powers first, I should say. So 1 squared is 1. And then the multiplication, we've got -4 multiplied by 1 multiplied by -6, that's plus 24 all over 2. So we get -1 plus or minus the square root of 25 all over 2. So hopefully you agree with me. I'm sure you do agree with me. Square root of 25 is 5. So one of our solutions is -1 plus 5 over 2, and the other one is negative 1 subtract 5 over 2. So let's check this. Negative 1 plus 5, that's 4, divided by 2, 2. And negative 1 subtract 5, negative 6, divided by 2 gives us negative 3. Exactly the same solutions as if we'd factorize it. And for this example, if we go back to our original example, we would never have used the quadratic formula. My point here in using the same example was to show that it does actually work. You would only use the quadratic formula if you can't factorize this. It will always work, so you can use it, it's up to you, but I would always look to factorize first. Goodbye, and thanks for watching.